Good
morning.
Just waiting for a couple of people to join us. Okay. Okay, are we ready to start?
Yeah, just a second.
Okay. Okay. Good morning, everyone. I'm Daniela Gonzalez, part of the supply chain research group at WMG, University of Warwick. It's a pleasure to welcome you to today's HIAC webinar, UK Hydrogen Supply Chain, UK's Capability, Readiness, and Strategic Challenges. Before we begin, I'd like to inform you that this session is being recorded to ensure we can share these insights with a wider audience. For the Q&A session, please raise your hand or use the chat function to submit your questions, and we will address as many as possible toward the end of the session. Our speaker today is Professor Alok Choudhary. Alok is Professor of Supply Chain Management and the head of the Supply Chain Research Group at WMG, the University of Warwick. Thank you very much, Alok. All yours.
We cannot hear you, Alok.
You know, we have been trying to resolve this issue for many, many months, but still, like when my session starts, it shows muted, and the camera is off. But I hope you can see me and you can hear me well.
Yes, yes.
Great stuff. Great stuff. Good morning, everyone, and a very warm welcome to our session. And in this session in particular, we are gonna just let me minimize this. Yeah, can you see my screen? Everyone see my screen?
Yes.
Yes. Great. So in this session, over the next 35 to 45 minutes, we will talk about the work that we have been doing in the context of UK hydrogen supply chain and the work that we have done, particularly to assess the supply chain availability and also readiness, but also understanding the strategic challenges that we have in the context of UK. A bit of background about myself. Alok Choudhary. I'm a professor of supply chain management, but I also head supply chain research group here at Warwick University. And I'm not sure if I'm just assume that you may be familiar with WMG, but it's WMG stands for Warwick Manufacturing Group, one of the largest, not one of the largest, but the largest department at the Warwick University. WMG is also a high value manufacturing catapult, which means that we quite a lot focus on, industry engagement and developing research, which is relatively higher TRL in comparison. So that gives you a bit of background information about me and WMG. Within the context of this is the diagram I assume pretty much all of you might be familiar with. So we have got four work packages, and as far as supply chain is concerned, it's pretty much cross-cutting theme across different work packages. So we, over the last year or so, we focused quite a lot of our work, particularly around work package 1, where we build upon the work done in task 1.1, which is on technology roadmaps. And building on technology roadmaps, we have focused our work around supply chain availability. And that is mainly to understand mapping the hydrogen supply chain in the context of UK, understanding how there are dependencies across different stages of supply chain, and assessing the supply chain requirement. A major part of our work has focused on understanding what we have got in the UK in terms of the supply chain availability. So when we look at different stages of supply chain, each stage of supply chain involves different components, different systems and subsystems needed. So trying to get a clearer understanding of whether the availability of supply chain that we have in the UK is ready for the future, or are there risks that we need to address? And at the same time, we will also be going forward contributing to now pretty much focused around the cyber physical systems work package 3, and that's where we will focus a little bit more on going forward. But what we're going to talk about over the next half an hour, 35 minutes, is predominantly the work we have done around supply chain aspects over the last year or so. So if we look at the hydrogen supply chain availability and the methodology that we have, it's a mixed methodology that we have used, which assessed a combination of methods. Like we use desk-based research, we have numerous interviews, we have a number of focus groups and workshops conducted, and that involved over 60 companies from across the UK in terms of coming to the findings of our research. But then we also kind of investigated in terms of desk-based over 170 companies, and these were mainly analyzed to understand the capability of the companies in the UK. And through this assessment, we looked for what is the current state of supply chain in hydrogen with regard to what are these companies doing, which aspects of supply chain they are addressing, and so on and so forth. And at the same time, we had a workshop where we kind of developed also the SWOT analysis to kind of get a clearer perspective on what are the key challenges, what are the key strengths and weaknesses and opportunities and threats for the UK context for when it comes to hydrogen supply chain. So that's kind of a brief overview in terms of the stakeholder that we engaged and our approach of conducting research. As I mentioned at the very beginning, that we started our work building on the work done by colleagues in task 1.1. So the first task 1.1, Dawai and his team predominantly focused on developing hydrogen technology roadmap. And our focus on that how we can use this technology roadmap and then implement our methodology on these 9 technologies with 13 technology items that you see, which is highlighted in bold color in each of these boxes. So we classified into when you look at the supply chain, we started from the production. Again, going back to one of the perhaps limitations, we didn't go too much into the raw material at this stage because the focus is predominantly looking at the state of UK supply chain. So we focus predominantly on dividing our work around production, storage, distribution, and in-use applications, right? And that is very much consistent with the task 1.1. And we looked at 9 technologies and 13 technologies items that you see here. So building on task 1.1, we focused on these technology and focus on the supply chain needs and availability of these components and technologies. So going back a little bit more into the assessment. So as I said, we investigated close to 177 companies across the UK. And within that, if you look at the state of different companies, you have got about 40% of the companies, up to 43%, which focus on the subsystem providers component or material provider for the supply chain. Then you have got 32% of the companies, which is either in product manufacturer or systems integrator, and 28% of the companies which are very much focused on infrastructure project developers, operators, and service providers. if you talk about, say, things like different way of classifying it. So, for example, 43% of the companies involved in, sorry, 43 companies involved in production, around 49 or 50 companies involved in propulsion. So we have this chart kind of signifying what companies are there and in what kind of their supply chain contributions look like. You have got big companies like JCB, for example, Rolls-Royce, Siemens Energy as like in product manufacturer. Then you also have a lot of companies who comes under component manufacturing. So things like Langsfield, Wefco, then Sheffield cylinders, they kind of provide hydrogen storage tanks. And then you have got Tata Steel and Liberty Pipes who provide very much the infrastructure and the network that is needed. So building from there, our whole interest was that how can we assess the availability in the context of supply chain, and building on that, having done the research and done quite a lot of literature review to understand there are three criteria. One of the interests that we have was there is quite a lot of fragmented research that is going across the UK when we talk about the hydrogen supply chain. So, for example, there is a lot of work, some of the work that's being done in the context of Hydrogen Innovation Initiative. Then we have an organization called Hydrogen UK. They also do some research looking at the state of hydrogen supply chain. So, but our work was pretty much distinct than them. But what we were trying our best to ensure that we are aligned and we are complementing any of the existing work that's been done in the context of UK. So with that in mind, we came up with this, what we call as these three criteria, looking at market readiness index, innovation capacity score, and competitive manufacturing benchmarking score, allowing us to what we call as quantify the availability and assessment of every stage of hydrogen supply chain. So these are the criteria we used to assess the hydrogen supply chain availability in the context of UK. Now, as I mentioned, we focused on 3 or 4 different stages, but to start with production, so if you look at the production stages, we have got close to 52 companies. And on the right-hand side, you will see that these companies are kind of pretty much geographically located, how these companies are geographically located in terms of the GIS and location of these companies. So we have 52 companies who are pretty much of that. 50% are infrastructure project developers, 20% in product manufacturers, 30% of these companies who are kind of, component and material supply chain providers. If we look at the more detail of these in terms of their capabilities, this gives you kind of, a little bit more in-depth view of individual of these companies. So if you look at hydrogen production, it's mainly consists of, you have got electrolyzers, you have got carbon capture enabling hydrogen production. Then you have also got electrical and thermal consisting of power electronics and thermal management systems and so on and so forth. So because our focus was on electrolytic hydrogen, we assigned electrical and thermal to the hydrogen production stage. So that's kind of an assumption that we had here. But it gives you kind of clear picture of pretty much a number of companies who are involved in what stage and what is their kind of capability in the UK. And it kind of gives us a kind of 360-degree eyes views of. We have got a lot more detail in the form of a database that allows us to kind of a little bit dig more deeper into these companies, and perhaps with new companies coming up, we should be in a position to update them and make it more dynamic. So if we look at in the context of the diagram here, if we look at the hydrogen demand that's been projected in 2030 and 2035, we are looking at 38 terawatt hours of demand in the context of 2030. And that doesn't include the use of hydrogen for blending into the gas grids, right? And it gives you kind of, on the left-hand side, it gives kind of variation industry by industry. By 2035, we are looking at, if we go by the assumptions that we are looking at 55 to 165 terawatt hours of under the 6th carbon budget. So these all are kind of taken from the industry and policy reports generally provided by DENS and organizations like that. The significance of sewing is this is what our ambition is. If we were to decarbonize UK's supply chain, this is what our ambition is and what role hydrogen has to play. But then we also need to assess where we are in terms of current availability. So if you look at the if you look at the current state of it, the way we are progressing, we pretty much need to exponentially year by year increase our capacity. And what it means is that in order for us to catch up with these numbers, where we are talking about 38 terawatts of by 2030 and 55 to 165 terawatts, there are a lot of projects that's been planned, which is kind of planned for 21.5 gigawatts for project pipelines that we already have. We have got 0.1 gigawatts of low carbon hydrogen production capacity for now. But if we were to achieve the government ambition of 10 gigawatt by 2030, we need to exponentially increase. And what it also means, if you look at the diagram year by year, we need to pretty much double down our production year by year to catch up with the government ambition, and which in itself is telling that it's very, very difficult task unless we try to focus on meeting the we pretty much double down our production capacity. So that gives you the kind of challenges that lie in front of us. So we have got the ambition, but the current state that we have is not really moving in the direction of the ambition that we have. So there's a big challenge here, because if you're going to double down your capacity year by year, that it also means that it needs supporting infrastructure, it needs supporting components, it needs supporting supply chain that needs to be in place to support that need, which again is a major challenge. If we further drill down in terms of into our further assessment, so if you look at, I talked about a number of criteria, that how we use those criteria to calculate the availability assessment. In this context, what you see here is that we looked at, say, for example, different components that goes on to make the production stage. So we have got different items on the left-hand side, and then you see different criteria that's being used, right? And based on those criteria, we calculate what we call as availability score. So in terms of the availability score, pretty much if you look at the availability score for electrolyzer stack, we have got a very strong EU and US support programs, which basically currently overshadow the UK's offering. But at the same time, if you look at the carbon capture package, again, the availability score, and that availability score 2.75 is out of 5. Right? So the UK currently has no domestic fabrication capacity for carbon capture packages. That came from the report in 2024, Hydrogen UK report in 2024. Again, if you look at the reformer package, we have got the lack of domestic manufacturing capacity with fabrication yards in the UK that seem to be kind of deemed insufficient for reformer package that we need. So, I mean, the score 1.75 literally signify that we are in a very poor situation when it comes to reformer package. Then you have got power electronics. We are doing a little bit better there, particularly in the context of you have got Williamson Advanced Engineering, great role played by Rolls-Royce, for example, or Turntide Technologies. These are kind of helping us with regard to power electronics that is needed at the hydrogen production stage. Moving on to the next stage, which is the storage and distribution capabilities. Again, we identified 59 companies. Again, here you can see on the right-hand side, different companies, particularly which is talking about in-product manufacturer or infrastructure project developers. That's kind of highlighted in blue color. Then you have got component and material supply chain provider in pretty much in gray color here on the right-hand side. But what it signifies that of those about 60 companies, you have got 44% of these companies are kind of component and material provider, 29 or 30% of the independent product manufacturer, and 27% of these companies are infrastructure project developers. Similar way, we further deep dive into it. We identified which those companies are, what they do, and in terms of their distribution. So if you look at 36% of the company in this particular context, that you will see are the storage provider, 54% are distribution and control, 25% are conditioning, and basically the chart here provides pretty much the naming those different companies that you have in the UK. There may be companies which is coming up. There may be companies which are at the startup stage, which we might not have captured. But as I said, our desk-based research tried to build in the work done by Hydrogen Innovation Initiative, but also manually looking at different sort of databases, which allowed us to capture the nuances of and the capacity and capabilities of some of these companies. So this gives a kind of clearer picture of what we have got available in the UK when it comes to storage and distribution capabilities in the UK. Now, moving on to the next stage, we look at within the storage and distribution, just to give you a little bit of further insight on. You can see different sort of salt caverns and these regions on the right hand side where these projects are. For example, you have got Cheshire Basin in northwest, East Yorkshire. You have got northeast. Then you have got the Wessex Basin in here in south coast. These are kind of giving us a kind of relatively clear picture of, and it also highlights their UK hydrogen storage capacity. So on the left hand side, if we are very optimistic, it gives us kind of estimation of hydrogen storage requirement going back up to 2025, both the pessimistic and the optimistic calculations. And then also it talks about the storage capacity that we have across different UK regions. Yeah. It also the most attractive long-term storage option for hydrogen in the UK. It's durable and affordable. It's also best storage capacities, very well established technologies. So in the context of UK, salt caverns are still the preferred option over other approaches due to their durability and affordability, right? So that's kind of current state coming back both from the data from British Geological Surveys and the another research that's been done across the UK. Now, in the similar way, like the way conducted the availability assessment using different criteria, if you look at here, compressed storage tanks, if you look at, there are 13 companies identified as capable of manufacturing type 1 of steel-based and type 4 of carbon fiber-based pressure vessels. So that's kind of making it but still the availability score is 2.75, and it still needs kind of a lot of improvement there. If we look at the hydrogen compressors, it's established, but still room for improvement. If we look at the air separation unit, particularly in the UK context, to the best of our knowledge, no existing manufacturing or R&D capability in the UK when it comes to air separation units. And then also you have got the large scale storage or salt cavern. That's, as I emphasized, quite a lot of focus we have got here. So the lot of R&D capability, lot of global competitiveness we have got suitable manufacturers, and therefore we are in a relatively comfortable situation there. And as I mentioned, that UK salt caverns are considered as the preferred option over other approaches due to their durability and availability. Again, similar is the case with hydrogen existing pipe network and hydrogen refueling stations. It's all coming up, but again, there's a lot of room for improvement in terms of having those pipe networks. How what sort of what we call as mechanisms we need to have in place to ensure that existing pipe networks could be used and there's a lot of research going on in that particular space. So while there's a lot of specialization we have got a lot of capability, but when it comes to having the suitable manufacturers or the global competitiveness, we are lacking far behind in that one. But at the same time, we have got a lot of industry specialization for refueling stations. We have got great deal of R&D capability, but we're still lacking in terms of having those suitable manufacturers for hydrogen refueling stations. So that gives you kind of a bit of idea of where we are in terms of use of existing pipe networks and the refueling stations. When it comes to the hydrogen in use applications, we have identified pretty much close to 100 companies. And out of that, again, going back to on the right hand side, you see the GIS, which highlights which are those companies and which sector those belongs to, whether it's in product manufacturer or whether it's infrastructure project developers or whether it's just the component or material supply chain. If we further deep dive into it, about 40% of the companies, mainly component providers, about 41% in product manufacturer, about 20% infrastructure project developers out of those 95 companies that's been identified through our desk-based research. If we further deep dive into it in terms of in-use applications, again, we have got the capability analysis. So it gives you kind of further deep dive into whether these companies are like feedstock. About 8% of the companies provide feedstock. Then you have got about 50, more than half is propulsion, power generations, and about 6% heat generation, 24% metering, and 18% of the companies providing mixed services. If we look at a mix of it, I think it gives us an indication that the number of companies that is coming up in the in-use application is rising every year. And again, quite a lot of big players, particularly if when you look at the companies likes of Rolls-Royce, companies likes of Intelligent Energy, companies likes of even Morgan Advanced Materials through to Johnson Matthey, quite a lot happening in that space. Cummins, you have got Bosch, quite a lot of companies that kind of we have been able to touch base with and coming big and have got a lot of R&D space going on. They are a lot more keen on what a lot of companies, they're like kind of watching and waiting as well, but they are still progressing a lot when it comes to R&D capability, as well as understanding how government is moving in that space. And quite a lot is again dependent on the government policy to see that acceleration happening with some of these companies. If we look again in terms of the availability assessment based on the criteria that we have, gas turbines, the UK has limited manufacturing capabilities for a small to medium size scale gas turbines, or also we have got some big players or aero-derived turbines. We have got excellent R&D capability, and that's across different areas, whether it's industrial burners, we have got fuel cell electric vehicles, excellent R&D capabilities. But when it comes to things like suitable manufacturers, particularly for gas turbines and fuel cell electric vehicles, we still need to catch up. We still need to further improve our capability and capacity in those areas. And same is also true for industry specialization when it comes to fuel cell electric vehicle and gas turbines. And therefore, when you look at the availability score in the context of UK, only the industrial burners kind of in a much comfortable stage in comparison to gas turbines or fuel cell electric vehicles. If you talk about industrial burners, predominantly UK has got a very robust network of industrial burner companies, companies like Dunphy Combustion or companies like Limsfield Combustion. They're kind of coming up big in this particular space. Now, having done that, looking at all three stages, one of the things that we looked at also trying to understand in terms of availability assessment, what is the SWOT analysis saying? So as I mentioned that we built on the work done by Hydrogen UK, Hydrogen Innovation Initiative, all sort of work that's been done in this space. But then we also engaged with a number of companies who are operating in the wider context of hydrogen supply chain. Then we also have a workshop conducted where we brought together about 50 companies, and we divided those companies into different stages of hydrogen supply chain. So a number of companies focused on hydrogen production, then a storage and distribution, and then in-use application. And then we have pretty much synthesized the strength, weakness, and opportunities and threat corresponding to number one, each stage of supply chain, and number two, overall in totality. So having a bird's eye view of hydrogen supply chain. So what I'm presenting to you, while we have got the analysis done for each stage of supply chain, but in the interest of time, we'll just talk about the SWOT analysis in terms of totality of hydrogen supply chain. So if you look at the strength, we have got particular strength, particularly around having early number of cluster projects, having a clear focus around policy on UK hydrogen strategy. Why it's changing, right? We have got a dynamic government systems. When we have got the previous government, the strategy, particularly in certain sector, was different than what we have currently now in the new government. So again, why? But there is a clear willingness of implementing UK hydrogen strategy, right? One of the we have got one of the Europe's biggest potential market. So lot of investment potential there, lot of industrial and academic research expertise. So if you look at the assessment that I have presented across all three stages, one thing that was very, very clear, that we have very strong R&D investment as well as R&D capability across hydrogen supply chain. We also have got a skilled workforce in certain sector. Skills is an area which is coming up big, which again, while it's a strength, but there are areas where it's also a challenge. Then you have got a reusable assets and know-how for hydrogen transition. So there's a lot happening in that space of reusability, or what you call, how can we use the existing infrastructure through to different networks that we have. So that's kind of a strength. Then you also have a strong storage capabilities, particularly around salt caverns that you see. That is an area which we are doing particularly well. We have got offshore wind leadership support, green hydrogen, and also multiple hydrogen developers and off-takers ready to scale up. So now we talking about the scale up. There is a lot of, again, potential there to improve, but that's the current state, that we still have a lot of potential for certain companies to scale up. Opportunities exist, particularly around converting the gas networks and scaling new projects, expanding workforce training and industrial roles. So quite a lot of initiatives, particularly going around skills and training and so on and so forth. Then there is also leveraging upcoming projects and the sourcing decision around that. We have got a clear opportunity for the international demand for hydrogen technology and services. So when we think of, while we quite a lot of we focused around the meeting the need of the hydrogen demand in the UK, but there's a clear opportunity that exists, that how UK can specialize itself and tap into the international demand for hydrogen technology and services, products and subsystem that goes on to make hydrogen supply chain, particularly for the international market. There's a lot of sectoral collaboration that opportunity exists there. R&D, establishing ourselves as a big player in R&D leadership, particularly when it comes to next generation of electrolyzer and storage capacity. Then also replicating the renewable energy success to draw hydrogen investors. Quite a lot of appetite there, and a lot of agencies are working. A lot of initiatives that's been put together to kind of attract more and more investors when it comes to looking at the opportunities that exist in looking at the gaps within the hydrogen supply chain in the UK, and then using those gaps as a potential business case that can be presented to the investors. And also then opportunity exists in terms of reducing outsourcing and enhancing the UK-based productions. Again, as I said, weakness, I think we are going through kind of really turbulent situation when it comes to the government policies and government's interest and government's priorities, for example. So just to give you an example, last year I was pretty much preparing my slides when we were talking about ban of our heating pumps that we use at our houses, and government lifted that ban that was planned for 2035, and they said they made it optional. So quite a lot happening now. Again, we are not sure. There's a lot happening in other sectors. So quite a lot of focus moving to defense and all that sort of thing. So we don't know, with the geopolitics going on and also what's happening in the US for the time being, how the government supports and the investor confidence will move towards the hydrogen sector. So that's an area which I would consider as a weakness. Current financial intensive basically trail government competitors, global competitors. if we talk about the specialized hydrogen equipments, we have got fewer overall equipment manufacturers. So scaling up might be a problem there. Production expenses inhibit mass production. If you look at the R&D capability, while we have got a strong, R&D capability, again, that needs to scale up. So currently insufficient help bridging the R&D to commercialization, that gap that exists between, how university research likes up TRL 5, 4, how that can be moved up to level TRL 7, so that element around commercialization, around moving that R&D through to commercialization phase, that gaps need filling up. Unclear scale up pathways, which basically complicates our planning. And also there's a big challenge here in terms of social acceptance, societal acceptance. And I will also relate this to investors' confidence. So there is still that lack of confidence among the investors, but not only among the investors, but also there's a lot of companies who are just like waiting and watching which direction things will go. So there is a kind of bit of poor communication, which kind of slows down the societal acceptance, and also emphasis on cheapest supplier over local benefits. So things like over dependency on, Southeast Asian companies, particularly China, that's kind of coming up as a key weakness. Then when it comes to threats, again, EU, US, a lot of Asian countries coming up big with substantial incentives and funding. And if we compare that, I think we see it as a threat. Low-cost components like undercut domestic suppliers. Again, we are trying to focus on net zero, and things like a lot of efforts need to be done in the context of reshoring of manufacturing of these components. Again, there is a missing component stall projects. There is also cybersecurity concerns that came up in our research. And then you have got things like, inaction risks losing early mover advantage. Also, insufficient skills and training program hamper our growth. And also there is a competing renewable demand. So when you look at in totality, well, there are certain areas where we are really, really excelling, but then there are areas where we still need to kind of, have a lot of weakness that needs to focus, but we also need to consider the threats that we have in a global environment that we operate. So that's kind of gives you a 360-degree picture of overall SWOT analysis of hydrogen supply chain availability. Moving on to the next stage, when you look at it, our ultimate goal is to completely understand the hydrogen supply chain mapping. It looks like a complicated diagram, but this shows you the dependency and different stages of supply chain, starting from the input, whether it's terms of raw material or feedstock resources, coming in different forms, moving on to producing hydrogen and different ways of producing hydrogen, and different types of producing hydrogen, through to how different mechanisms could be used to move hydrogen through in terms of transportation means, and also different types of storage options that we have. And also then you have got the final end use of hydrogen, whether you go about home heating or whether you go about using it for refineries. And then also, things like whether you're going to use it for trucking options or even for aviation. So in this diagram, it looks simple, but it's too complicated when you look into the detail of it and the dependency it has on different stages of supply chain. So again, our goal is to map that each stage of supply chain, ensure the hydrogen availability in the UK to achieve that vision we have for net zero by 2050. Yeah. So if you look at the outer ring, it mainly focuses on the raw material that we have not looked into currently. Raw material that raw material that goes on to say, even for example, we talk about electrolyzers, right? When you look at the raw materials that is needed to produce those electrolyzers, it's if you are a supply chain expert, it's the one of the highest risk that you will see. Simple reason being that the geographies that it is coming from is highly concentrated in a specific part of the world. And that makes it more and more vulnerable because you have got that sole dependency in particular areas and particular countries. So again, then going back to further down, you have got the raw materials, you have got the manufacturing parts and equipments, and then you have got the assembly of components and parts. So again, the next stage for us is to kind of a little bit more deep dive into these and further going. So this is what we have done so far. Going forward, the whole intention is that how we can deep dive into the assess that supply chain mapping and look at and evaluate supply chain components and identify its strengths and weaknesses. So we look at the end-to-end supply chain. We support resilience and readiness. So we have got two different models that we are talking about. One is hydrogen supply chain readiness model and hydrogen supply chain network design. And these are basically enables us to immediately we focus on assessing the readiness, particularly by preparing quantitative models that can allow us for looking at the hydrogen delivery to meet future energy demands. And then also based on that, developing some sort of roadmap and action plans to bridge the gaps and ensure resources are in place to meet those demands. If we look at the hydrogen readiness model, again, the approach we have is particularly looking at the what we call as looking at those different defining hydrogen supply chain components across the wider diagram that I have shown to you, extract the main components for the mapping and looking at, what are those individual components that is needed and doing that detailed hydrogen supply chain mapping and use those to then further assess the readiness model using a quantitative indicator and then assess the hydrogen supply chain readiness in the context of hydrogen supply chain and building on that, develop the strategy roadmap and action plan to bridge those gaps in the context of UK. Building on that, again, I think we have also proposed to develop, some sort of collecting data around infrastructure data that we have, considering the local, regional, and national perspective. Using those data and mapping the supply chain, developing different sort of simulation models and scenario planning, which will basically form the part of our work in work package 3. By that way, being able to demonstrate again, linking back the availability, but also being able to demonstrate the risk that may exist in the context of supply chain. And building on that also, if we are able to look at some sort of circular economy business models or techno-economic parameters that could be embedded in the optimization models to ensure that the design, the network design that we have for hydrogen supply chain is taking into account some of those parameters that is coming from resilience as well as those circular economy objectives. That's the kind of piece of work going forward. So with that, I will stop. And I understand that there's a lot of information to grasp, but I'm happy to kind of take any question you may have. Thank you for listening.
Thank you very much, Alok. Yes, well, moving to the Q&A session. Contributing to the Q&A session is Dr. Hamed Kalantari, who will contribute to answering the key question with Alok related to the topic that we discussed today. Looking at the chat, there's a couple of interesting questions. For example, do you have any thoughts or what proportion of the supply chain will be UK-based versus international and the mechanisms that should we put in place to maximize local content?
What do you need to, this is like, honestly, this question is very interesting question, and it does not necessarily only apply to hydrogen. It applies to pretty much every energy factors that you have, whether it's about electric vehicle or even in hydrogen space and even in multiple other areas. But that's very interesting question. So one of the things that what we have been doing is to understand what component that we have got, that what are the companies in the UK who produce those individual components, right? And then at the same time, also trying to understand what are the raw material that is needed to make needed to make those components, right? But when you go to that level of supply chain where we are looking at the raw materials that is needed to make those components, at this stage, we are far, I mean, it's the most vulnerable area when you look at it, because the raw materials that is needed, those raw materials are also needed for other energy factors, right? So it's difficult to say there is and the another challenge is that a lot of it is coming from, you know, certain parts of the world, right? While we have in the last few years started to focus on developing those critical minerals and materials, but we are still very limited in those areas. So I think we are not gonna separate. The focus is going to have, the way I see it, that the focus is quite a lot is going on the component manufacturing by government incentives, by new regulations coming up, which will promote UK manufacturing. But the way I see it is that still those manufacturing are going to have heavy reliance on overseas companies for the components and parts which are not high value, and at the same time also a lot more dependency, particularly for the raw material. I hope that kind of try to, but it's difficult to kind of say, well, this is 50% or 40%. It's difficult to say at this stage. It all depends on how quickly we are able to catch up with the demand that we have got in front of us.
Yeah, well, talking about demand, a question from Nashwan, can you please elaborate on where the end user and demand will be coming from?
Interestingly, I think, again, I will involve Hamid as well on this one.
Yeah, thank you very much.
When you look at the demand, and, you know, well, so one is that in the context of this project that what we have focused on so far, we predominantly focused on the demand in the context of UK. So when I say demand, that's projected demand for the UK, right? But not to forget that we operate in a global environment, right? And if you look at how things will progress, there will be global demands which is going to significantly increase, and therefore greater opportunity lies there, where UK companies and the R&D capability that we have built up can also serve the global demand, particularly when it comes to those components and those parts and different stages of hydrogen supply chain that I mentioned. So when we look at demand, while the sphere and the focus of our work has predominantly focused on the UK demand, but as we progress forward, there is a global demand that we need to consider. And again, we work in a global environment, so again, we need to consider those in demand as well.
Alok, just
Hamid,
a quick,
over to you.
Just a quick answer for demand from my side. I think basically demand will primarily come from industrial and commercial sectors. I think it as projected at 19 to 141 terawatt hours by 2050. And after that, we can say that end user in residential heating will grow with about 15 to 200 terawatt by 2015. And after that, we will have transportation. Power generation, maybe we'll collaborate a smaller demand around 1 to 22 terawatt hours. Yeah.
Okay, we have another question from David Flynn. UK gas network operators feel that often want to decommission the gas network. Does the supply chain share this view or concern?
Sorry, can I just get sorry, I didn't see that question. So
I don't know if David, if you want to open your mic and elaborate on that question.
Yeah, absolutely.
Oh, sorry.
No
Yeah,
problem.
David, sorry.
Hi,
Like
David.
I couldn't see the chat box until now, and yeah.
No problem at all. Brilliant presentation. Thank you very much. Indeed, a lot of rich information to digest. So my question was, because supply chain growth and capability building is all about confidence. It's all about meeting a growing demand. And I wondered if the supply chain networks you engaged with had similar concerns about the future of the UK gas network, which relates to its potential decommissioning.
Yeah. I think that you're right. I think there is a multiple concerns coming up, and there is still not there like tangible response to these questions, either the with greater confidence from the government or with the greater confidence from the things like, say, for example, different gas networks. When we had the workshop, we had a couple of companies who were part of the gas networks, and they raised a similar sort of concern around whether the existing gas network could be used, but there is still a big uncertainty down there. So we haven't got that confidence yet fully from some of the companies who participated in the network. It comes down to their whether those networks could hold down to the pressure that is needed to maintain hydrogen flow. At the same time, also the regulations that may drive some of it from coming from the government. So quite a lot of consideration that still needs to happen in that space. And again, if we are really serious about it, we need to honestly address these issues, but that won't be possible without some greater driving force coming from the policymakers and the big players who are there in this sector.
Thank you very much.
And can I provide a short answer?
Yes, sure,
Alok?
Hamid.
Thank you very much. I think from my perspective, the supply chain does not fully share Afghan's perceived push to decommission the gas network. Instead, a stakeholder in our interview and also our workshop in our research saw a significant opportunity in repurposing existing network, as Alok said, for hydrogen, that will align with the view of gas network operator who maybe not fully accept this decommission, but from the stakeholder and industry perspective, maybe we can say and estimate that we may have a repurpose for existing network in this case.
Yeah. Thank you both for your responses. And just brief before I hand over to your next question, is that, we have the next 5-year plans, billions of pounds detailed. I think it's very interesting that, given both of your responses, that we really do need to understand the readiness and the potential capacity of that gas network, especially when we see such a drive in the clean power 2030 agenda. I think we've got something really interesting to look at. But thank you for your replies. Thank you.
Thank you.
Thank you very much.
Ife?
And talking about target audience and stakeholder engagement, Thomas mentioned something that you highlighted, Alok, about the poor communication as a weakness to undermine the social acceptance. Please, could you say a bit more about that and maybe provide examples?
Yep.
Yeah, Alok, can I?
Yeah, please go ahead.
Yeah. I think, but I just talk about our research. Our research highlighted that unclear and limited communication about hydrogen benefits may be the safety that undermines public trust and acceptance. This would be a short answer. But from the perspective of impact on social acceptance, without effective outreach or misconception like safety concerns, showing adoption in sectors like domestic heating, I think we can talk about this question in these two aspects: poor communication and also impact on social acceptance.
I mean, I can just add something on that. The thing that has come very clearly is that uncertain environment and having people confidence both in policymakers and at the same time also on companies that they will be able to meet the demand. if you talk to even a number of companies, they clearly say, well, that's impossible. That's the kind of word that we hear from them, the kind of ambition we have versus the current state we have in the UK. And that is kind of, so it's a lot that if we have to make progress, again, communication needs to be clearer. And at the same time, it has to come from those policymakers. So policymakers need to be driving it with clearer communication. At this stage, there is still a lot of ambiguity. There is still a lot of uncertainty. And people, not when I say, don't say people, I would say rather stakeholders, right? And people, or whether it's companies, they still don't have got that confidence yet. So I think a clearer communication would definitely help. And that's what one of our key, I would say, weakness as well, I would say.
Yeah. And talking about the building the strength, there is another question.
Ife raising her hands. I'm not sure if that's me or.
Yeah.
Hi, look, that was a fabulous presentation, so very well done. And I suppose the question I'm asking on the back of your presentation is, I think, David hit on a point of it as well. So I suppose the first thing is the existing natural gas infrastructure across the UK. Then the injection and what we can blend in terms of hydrogen, and there may be other gases as well injected into the grid, I suppose. So that's the first thing I point out in all the conversations and narratives I've had with academic colleagues across the UK when I went to the RG20 out in Delhi in India before Christmas, and also when I've been speaking to various policy advisors and government advisors and politicians in Westminster, they're sort of forgetting that. So if we develop AD, okay, so anaerobic digestion, and I know people keep on knocking it on the head, but with energy security and the way farming is going, we just don't know, okay? So that's the first thing. The second thing then is, I suppose, Alok, and these are sort of guides for your research and where you're bringing this as a piece of work, and for other people in the room as well. Everybody is going to be doing this at the same time, okay? So when you say, based on the Geological Society's recommendations for salt cavern storage, okay, and they said it's the least cost, those sort of phrases are very generic. And based on my 30 years now in this industry, I've heard many people say it about wave energy, okay? And wave energy has had actually nearly 60 years of research, and it's not scaled. And we have many colleagues who research it and make those claims. And what we've learned from the Whitby experience is making claims to the public that don't stack up are actually reverse and counterproductive for net zero. So when you make those statements, I think you need to sort of caveat it, Alok, and we all do, in the context of other technologies, what's scaled up and what's not scaled up. And that's in a global context. What's cheap or what's inexpensive. You need to be very, very prescriptive, because I wouldn't want us to be in a situation where people say about my research or my work or the work that we've all done in a number of years' time was actually, that was just another research project. And it made commitments and statements and recommended to us different things that didn't work. Because if we want to grow this and we want to grow our hydrogen network, then we need to be very careful in how we present the facts and actually the engineering, okay? And it's a sort of a common theme at the moment across all research.
Yeah, the point is that, facts, we don't generate facts. For facts, we have to rely on those agencies and the one that has done those, like...
Alok, that's not the point I'm making, okay? And what I have to say to you is, the policy recommendations that they get are based on the policy recommendations that they get from people like us, because I do interviews for Westminster for briefing notes. I do off-gem interviews. I do other interviews that have been commissioned by other agencies, government agencies, where they ask me different facts and figures on electrolyzers, on how much we can blend in the network, what's cheap, okay? So when we make sort of general statements, and it's just something, we need to sort of compare and contrast in terms of what costs are and what can scale and what can't scale. And we also then need to say, when we say this, we're in a global supply chain, okay? Everybody's going to be competing. And based on historical trends, if we don't pony up, and if we look at, say, onshore wind turbines, when I was buying onshore wind turbines and developing wind farms, there was a waiting list, okay? It's like a nuclear plant. There's a waiting list with all these companies, and if we don't get in now and plan with technologies that do work, then we're going to be at the bottom of the waiting list. We'll run into an energy security issue, and then what we'll have to do is buy backup generation or gas generators that will meet a shortfall in our generation capacity, and our gas, we'd have to ramp up gas storage very quickly, natural gas storage. So they're the sort of things that I think when you're doing the work, and I recommend it to everybody, and when we're portraying what we're doing, that we include in the presentations. And we then could say, maybe have a little slide and say, here's what everybody is else doing. So it's like, they're all electrifying, they're all doing this, and based on these other papers, these are the issues. So we're flagging up to the policymakers that we won't, you know, that if we don't do the right thing, or we're telling them the facts, these are the facts, then they know what the risks are.
Very important discussion, and this topic make us engage with all of these conversations. But if there is more questions to elaborate, please feel free to reach out.
So just to say it, Alok, love the presentation, but they're the two things that I would say. The gas network, David alluded to it, because it's not going to go away, and we need to, because it's a huge pension hole to the, it's basically a semi-state by 2 degrees of separation, because your UCU pension is actually in Centrica and in those gas networks, okay? So it's a huge risk for the UK. One last comment, Alok. When you showed the UK, there was no Northern Ireland in terms of hydrogen activity for R&D and for manufacturing. There are some sites in Northern Ireland and some companies, and I will email you those separately. You did show Larne, but you didn't show what actually is going on in Northern Ireland. That's just a thing for me, because I came from Queens.
Thank you very much. I think,
cheers,
sorry, I have to go now. We just, thank you very much. That were really helpful comments. We'll take some of these into account. And yeah, thank you very much all. And I really look forward to continue this collaboration, working with you all.
Thank you very much for the participation and the discussions. Have a great day.
Thank you.
Bye-bye.
Thank you.
Thanks. Bye.
Thank you.